Okay, before we get too deep into this, I want you to understand that one thing, because this can get confusing. There's a major distinction between simplifying rational expressions and solving rational equations. A lot of people get these confused. The result, when you simplify a rational expression, will be just an expression. But the result from solving rational equations will be a numerical value. So, make sure you look at the answers from the previous problems, the expressions we did earlier, and then notice what we get when we solve these rational equations. Okay, so to solve rational equations, what you're going to need to do is you're going to need to find the lowest common denominator. Now here we're going to multiply each term by the lowest common denominator. Now previously when we were adding expressions, we were getting the lowest common denominator and we actually kept the denominator throughout the problem. But for solving rational equations, that's not the case. In solving rational equations, the idea is to use the lowest common denominator to eliminate the denominator, and the reason you can do that is because you have an equal sign with an equation. And so with the equal sign, that means I can multiply both sides of an equation by a number, and if I choose the lowest common denominator of whatever the denominator is, then that will eliminate the denominator. So let me show you what I have here. Now right here I have an equation. X plus 12 over x equals negative 7. Well, I know that the x term's denominator is 1 and the negative 7, its denominator is 1. So the lowest common denominator would simply be the denominator of x, which is x. So the lowest common denominator is just going to be x. And I'm just making a note here to remind you that x can't be 0 because remember 0 is not in the domain of this equation. Okay, now what I can do now is I can multiply x by this 12 over x, and that will eliminate the denominator because x over x is 1. But if I multiply this term by 12 over x, I got to multiply all terms by x. So if I multiply this term by x, I got to multiply the other terms by x as well. So I'm going to multiply x by x, and I'm going to multiply the minus 7 by x. And so x times x is x squared. And of course, when I multiply 12 over x by x, the x's cancel, and I just get 12. And then x times minus 7, that's actually going to equal minus 7x. Now, what I can do now is I notice this is actually going to be a quadratic equation. So if I move the minus 7x over to the other side here, then it becomes a plus 7x. And so I'll get a plus 7x on the right, and then since I moved everything over to the left, I get 0 on the right. And now I can factor this, and I can factor it, and it factors into x plus 4 times x plus 3. And remember, we learned how to solve equations by factoring using the zero product property. So if x plus 4 times x plus 3 equals 0, then either x plus 4 must be 0, which would mean x equals negative 4. I'm doing this part in my head here. And the other factor, x plus 3, would have to be 0. And if you solve that equation, x plus 3 equals 0 is x equal negative 3. Now, if that bothers you, then just write out over here somewhere, the equations x plus 4 equals 0, and then solve it, and then write out the other equation, x plus 3 equals 0, and solve it, and then you can see how I got the solutions negative 4 and negative 3. And the one thing you need to do, you always want to check your work on these, and you're not necessarily checking to see that you got the answer that made the equation true, which you can do that, but the thing is, you don't want to include an answer that's not in the domain. So just for instance, remember 0 is not in the domain here. So if I'd gotten a value, like if this had told me one of the answers was 0, then I wouldn't be able to use that answer because 0 is not in the domain. So we'll see an example like that in a bit. I believe I have one where you get an answer that doesn't work. Okay, so now again, this looks like what we were doing earlier with adding and subtracting, but there's a major difference. We have an equal sign here. So this is an equation. So now let's see if we can find what the lowest common denominator of these three terms are. First of all, let's rewrite it. Let's write the x squared minus 4 as x plus 2 times x minus 2. And so we have 2x over x plus 2 times x minus 2. And then we're going to add to that 1 over x minus 2, and that equals 2 over x plus 2. So since the lowest common denominator here is x plus 2 times x minus 2, I know if I multiply each of these terms by the x plus 2 and x minus 2, it will actually cancel each of the denominators. Before I do that, let me remind you here, since we can't divide by 0 in an expression, remember x cannot equal negative 2 because that would give us 0 here, and x cannot equal positive 2. So just keep an eye, keep an eye on that the domain cannot include 2 or negative 2. Okay, so now let's get back to this. So I'm going to take this fraction and I'm going to multiply it by the LCD here, x plus 2 times x minus 2. Now, since this is exactly the same as my denominator, then that will simply just cancel those denominators, will cancel with these factors, and all I'll get here is simply the 2x. And then when I multiply the next term, 1 over x minus 2, by x plus 2, x minus 2, the x minus 2's will cancel, and so I'll get 1 times x plus 2, which is just x plus 2. And then on the other side of the equal sign, I'm going to multiply 2 over x plus 2 times x plus 2, x minus 2. And here the x plus 2's will cancel, and so I'll get 2 times x minus 2 on the other side. Oops. So anyway, now I can multiply this out. 2 times x minus 2 would be 2x minus 4. And then over here I can combine like terms and I get 3x plus 6. Now, I assume by now you can solve this. Just subtract 2x from both sides and you'll get x over here, and then subtract 2 from both sides and you'll get negative 6 over here. So solving that equation is really not too difficult. So you get x equals negative 6. And that negative 6 is in the domain, so we don't have to worry about that. Now, let's take a look at this next one. 22 over 2p squared minus 9p minus 5 minus 3 over 2p plus 1 equals 2 over p minus 5. Well, if we write the first term with the denominator factored, notice it factors into 2p plus 1 and p minus 5. And that's a good thing, since the other denominators each have one of those factors. So this has a factor of 2p plus 1, this has a factor of p minus 5 in the denominator. So therefore that means that I can just use the 2p plus 1 times the p minus 5 for the lowest common denominator, and then I can just multiply each term by that. So if I multiply the first term by that, well, just like before, both of these are going to cancel with this, and so I'll get 22. And then if I multiply the second fraction by that, the 2p plus 1's will cancel, and I'll get minus 3 times p minus 5, which I wrote right here. And then on the other side of the equal sign, the p minus 5's will cancel when I multiply, and I'll get 2 times 2p plus 1. Now, over here, if you distribute the minus 3, that's going to give you minus 3p plus 15. And over here, if you distribute the 2, you're going to get 4p plus 2. And then 22 plus 15 can be added together to give you 37. So I have minus 3p plus 37 equals 4p plus 2. Now if you subtract 4p from both sides, say 4p from this side will cancel that, and then minus 3p minus 4p will give you negative 7p. And then if you subtract 37 from both sides, 37 minus 37 will cancel that, and then 2 minus 37 is negative 35. So you'll have negative 7p equals negative 35. So the answer appears to be p equals 5, because if you divide both sides by negative 7, you get p equals 5. But 5 is not in the domain. See, remember, one of the factors of one of our denominators has factors of p minus 5, and if p was 5, then that would give us a 0 in the denominator. Actually, it would give us a 0 in the denominator of both this fraction and this fraction. So p equal 5 is not in the domain, and since that's the only answer that's possible, then we have to say that this problem has no solution. Okay, I want to finish this section up on a special type of rational equation called a proportion. Now, a proportion is where you have a single fraction on each side of the equal sign. So notice here I have an equal sign, and on the left I have a single fraction, and on the right I have a single fraction. Now, I couldn't use the technique I'm going to use here on these problems because these problems have multiple fractions on one side or the other. So this only works, I'm going to cross multiply here, and the cross multiplication only works when you have a single fraction on each side, of the equal sign. So here the idea is when you have a proportion, the product of the numerator from one side to the denominator of the other side have to be equal. So if I take x minus 3 times x, that has to equal 8 times 5. And so then I can solve that equation, because that's going to be x squared minus 3x equals 40. And then subtract 40 from both sides, and I get x squared minus 3x minus 40 equals 0. And then that factors in x minus 8, x plus 5 equals 0. And then you set those equal to 0, and you get x equals 8 and x equals negative 5. And those are in the domain, so those answers both work. Now let me do one more here. On this example, if I cross multiply, I get x squared times x minus 4 equals 16 times x minus 4. Well, if I multiply x squared times x minus 4, I get x cubed minus 4x squared. And then 16 times x minus 4 gives me 16x minus 64. And then I can actually move both of these terms to the left, and so I'll get x cubed minus 4x squared, and of course their signs will change when I move them across the equal sign, minus 16x plus 64 equals 0. Now I'm going to factor by grouping. I can factor in x squared out of the first two terms, and I get x squared times x minus 4. I'm going to factor a negative 16 out of the second two terms, and I get negative 16 times x minus 4. Then I can factor in x minus 4 out of this first term, x squared times x minus 4. That'll leave me with x squared. And then if I factor x minus 4 out of here, it'll leave me with minus 16. And then the x squared minus 16 actually factors the difference of squares, x plus 4 times x minus 4. So it turns out the x minus 4 factor shows up twice. So I get x minus 4 equals 0 and x plus 4 equals 0. So x minus 4 equals 0, that would mean that x equals 4. X plus 4 equals 0 means that x equals negative 4. Okay, but one thing to remember, x cannot equal 4 because it's not in the domain. If you plug 4 into this expression, you get 0 in the denominator, and since you can't divide by 0, we know x equals 4 is not in the domain. So the only answer that works here is x equal negative 4. Okay, so that pretty much finishes the rational equations. And we'll see some more rational equations in the next section when I work some word problems for you.